Alright, so if we take a look at the warm-up, it's asking us if ABCD is a parallelogram. And it tells us a couple things about the unknowns. It tells us that this is 8x, and remember up here it tells us x is 9. So that means that this thing has to be 8 times 9, or 72 degrees. And then down at the next one, it tells us that D is 9y plus 9. So if y is 9, or if y is 11, we'll plug that in. This gives us 99. Plus 9 more will give us 108. So angle D equals 108. And then let's find some of this other stuff. This one over here is 10 times y, which is 11, minus 2. This is 110. Take away 2 will give us 108. So angle B is also 108. And then finally the last one tells us down here that this is x squared, so 9 squared minus 9. That's 81, take away 9, which will give us 72. So this angle here is exactly the same as this angle here. And then this angle here is identical to this one over here. So yes, it's a parallelogram, and we can say it's true because opposite angles are congruent. You could have gone a different way with this, and you could have said because 72 and 108 add up to 180, and 72 and 108 this way also add up to 180, that both of those are supplementary. That also tells us that it's a parallelogram. So remember, we had all of these conditions for parallelograms, and if you flip all the way over to the back of your paper, these are all of the conditions. So one of these has to be true in order for us to have a parallelogram. And we can draw some pictures of these. So the very first one is the definition of what a parallelogram is. Both pairs of opposite sides are parallel. So sometimes it will just be as simple as that. They will give us a shape, they'll say that this is parallel to this, and so are these ones. That right there tells us that it is a parallelogram. We'll call this 1 and 1. The next thing that could happen is that you have one pair of opposite sides that are parallel and congruent. So you have a parallelogram sitting there, and I'm going to tell you that this side's parallel to that side, but it's also the same length. That tells us that it has to be a parallelogram, that these two sides also have to be parallel, even though they don't come out and tell us. Let's draw that back in. So the third condition that could be met is that both pairs of opposite sides are congruent. So again, you can have a parallelogram or a shape out in space, and if I tell you that those sides are congruent and those sides are congruent, it has to be a parallelogram. So another one. Let's say both pairs of opposite angles are congruent. That's the one we just had. So if I tell you that this angle is congruent to that one, and this angle is congruent to that one, you know you have to have a parallelogram. If we slide on down, we got two more conditions that could be met. 5 says one angle is supplementary to both of its consecutive angles. So that means we have this shape again, quadrilateral. And if this is 80 and this is, or sorry, x, and this is 180 minus x, and so is this one, that means that both of these guys are supplementary. So when that happens, it has to be a parallelogram. And finally, the last one, number 6, is when the diagonals bisect each other. So again, if you are given a quadrilateral and you have diagonals that go through it, and then they tell you that this is congruent to this, and this part's congruent to that part, then it must mean that they bisect each other and you have a parallelogram. So in today's lesson, what we're going to do is we're going to graph something on the coordinate plane, and then we are going to prove that it's a parallelogram using whatever definition they tell us to. So for this one, it says, show that quadrilateral JKLM is a parallelogram by using the definition of a parallelogram. If you forgot what that is, the definition of a parallelogram is that both pairs of opposite sides are parallel. So that's what we're going to need for this one. So the first thing we're going to do is put this on our paper. So -1, -6 is J. K is at -4, -1. L is at 4, 5. And M is at 7, 0. So there's our shape. And we need to prove that both sets of opposite sides are parallel. So our first set of sides, JK, its slope is down 1, 2, 3, 4, 5 over 1, 2, 3. And then that should be parallel with LM. So the slope here is 1, 2, 3, 4, 5 over 1, 2, 3. And because these slopes are the same, we know that JK is parallel to LM. So now we gotta do the same thing for the other two sides. So KL, up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8. 6, 8. And then we gotta prove that that's parallel to JM. So 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8. So again, because these slopes are the same, we know that KL is parallel to JM. So because we have both of these things, we just use the definition of a parallelogram to prove that this in fact is a parallelogram. So now the next one, we have ABCD. Let's put it on there. A is at over 2 up 3. B is at over 6 up 2. C is at 5, 0. And D is at 1, 1. So a lot smaller. And this time they want us to use 6, 3, 1. So if we go back down here, 6, 3, 1 is this first theorem here. One pair of opposite sides are parallel and congruent. So when we come back up here, it doesn't really matter which one we pick. So let's pick A, B, and DC. We need to prove two things. We need to prove that they are parallel and that they are congruent. Now the parallel part's pretty easy. We're just going to count like we did last time. So AB, you go down 1 over 1, 2, 3, 4. So AB's slope is down 1 over 4. DC, I'm going to go down 1 over 1, 2, 3, 4. And guess what? They're the same. So now we know that AB is parallel to DC. So that's one part of it down. The next part is we need to prove that those lengths are congruent. So for that, we need to use the distance formula. And it's been a while since we've done the distance formula, but remember what you need to do is take your x values, subtract them, square that, add that to your y values that you subtract and square, and then take the square root of the whole thing. So A is at 2, 3, and B is at 6, 2. So the distance between them is going to be the square root of, subtract our x's, so 6 minus 2, square it. Subtract our y's, so 2 minus 3, and square it. This is 4 squared. This is -1 squared. We get 16 plus 1. So we're taking the square root of 17. And we can type that in our calculator if we want, or we can just leave it because this is actually a length here, the square root of 17. So let's just leave it. And now we got to do the same thing with the other distance, the DC. So again, take your x values, now they're these points, and subtract them. So we're going to do 1 minus 5 all squared. Then we're going to add that to our y values, which is 1 minus 0 all squared. So we get negative 4 squared plus 1 squared, which gives us the same thing. Luckily, we get 16 plus 1, which ends up being the square root of 17. So now that we know these distances are the same, we can write that AB is equal to CD. So using theorem 631, we have proved that opposite sides are not only parallel, because they have the same slope, they're congruent. So that means that that has to be a parallelogram. Last problem. The legs of a keyboard tray are connected by a bolt at their midpoints, which allows the tray to be raised or lowered. Why is Pqrs always a parallelogram? So they're having us look at Pqrs, this guy right here, and they're asking us why does this have to be a parallelogram, no matter how high or how low that table is. So think back to the information that they gave us. They said that the legs of a keyboard tray are connected by a bolt at their midpoints. So they're telling you that this right here is the midpoint of these two legs, which by definition means that this is congruent to this, and this is congruent to this. So we know that from P to E is congruent from E to R, and Q to E is congruent from E to S. So if we look back down here at our rules, it's this guy right here, theorem 635. So we can say by theorem 6-3-5 that Pqrs is always a parallelogram. And it's because the diagonals bisect each other. They cut each other in half. So it doesn't matter if it's up high or down low, it's still going to end up being a parallelogram. So these things right here, you need to just commit to memory. You have to know all of those. You do not need to memorize these. And on a test or a quiz, when you're given problems like this one right here, it won't just say by theorem 631, it'll say by proving that two sides are opposite and congruent. It's also a good idea to memorize these pictures. Sometimes the pictures help you figure things out rather than just the words. So make sure you know all of the different ways that you can have a parallelogram. If you have any questions about this, make sure you put a star or a circle or something next to it, and we can go over it in class tomorrow. We'll review 6.2 and 6.3 tomorrow, and then take a quiz on Wednesday, which is our PLC day, just like we had planned. Your homework is written on your purple stamp sheet, but it is page 402. You need to do 1 through 7 and 14 and 15. We'll check that in tomorrow and make sure there isn't any questions. Have a good day.